to our IoT sharing session today. We're pleased to be here. My name is Kim Irvine. I'm an associate professor in the Faculty of Architecture and Planning at Thammasat University. And I'm going to be starting the session this morning by looking at IoT applications in environmental courses in geography at the National Institute for Education in Singapore.
I'm Thithiporn Wongwacharaviwoon, Director of Design Business Technology Management. I will introduce circular economy to you and show some example of circular economy project in Thailand as well.
And we are currently in third year student DBTM. We're going to talk more about the application called Spring Bus. And my name is Parin Pakisuan.
My name is Sajin Vimonpithayara.
My name is Thilawan Jambik-Thawong.
Okay, thank you for the introductions. That was in the order of our presentations then this morning. And I will begin by looking at IoT sharing applications in geography. Good morning and welcome to our first session of the morning, IoT sharing applications in geography. As I mentioned, my name is Kim Irvine, and I'll be sharing with you today some of the work that we did in Singapore with IoT in our geography program, specifically with environmental applications. So the objectives for this session this morning are really, first of all, to look at how IoT has impacted pedagogy in the geography classroom at the National Institute for Education in Singapore. Specifically, I'm going to provide some examples of the AAG 10C, which is a year one course in techniques in geography. And in this course, the students learn how to graph data, how to analyze data statistically, and really focusing on applications of IoT with respect to NIE's meteorologic stations. The second example that I'm going to go through this morning is looking at a year 3 course, Catchment Management and Conservation. And in that class, the students used IoT data in the end to actually drive a mathematical model to look at how the model can represent water-sensitive urban design or rain garden in Singapore. And this is in line with real-world scenarios, and in particular the Singapore Smart Nation Initiative. Okay, so really what we're hoping to do here is to show how IoT can facilitate PCK or pedagogical content knowledge for teachers in at least a couple of different ways. First of all, what we found was that we frequently would get questions from teachers about how to use rain gardens in their classroom. Now, the Public Utilities Board, or PUB, Singapore's water agency, has been promoting construction of rain gardens throughout Singapore, but also at schools. And PUB sees this as a very good tool for water management and flood management within Singapore. However, sometimes the teachers are a little concerned, a little unsure about how to use the rain gardens in their class. And so what we really want to do here is show how you can translate the content information from the PUB with respect to urban design and rain gardens, and translate that into different levels in the classroom, whether it's primary school or secondary school or university level. Secondly, we want to really underscore some of the more complex applications of IoT. And in particular, we want to emphasize what we would say is that the tail shouldn't wag the dog. So in other words, we really want to make sure that the technology is not driving the learning, but rather the technology is supporting the learning, and that we have good, sound, theoretical learning base through PCK or pedagogical content knowledge. So turning to our first case example, the first year class, which was AAG 10C assignment in techniques in geography. And looking at the pedagogical considerations for this particular class, really what we were doing is having this class build on concepts that they had learned in the previous semester with respect to radiation and energy balances. So this is really climatology-oriented application. But in addition, we were introducing the students, because this is a techniques in geography class, we were introducing the students to applications in graphing and data analysis as well. So here we see in this particular slide, really the basis of what the students had learned in the previous semester with respect to radiation and energy balances. So the net energy balance, Q star, is related to K down, which is incoming shortwave radiation, minus K up, which is outgoing shortwave radiation, plus L down, incoming long wave radiation, minus L up, which is outgoing long wave radiation, and then QH is sensible heat, QE latent heat, and QG ground heat flux. So we see that the students should have an appreciation for how these different components of the total energy balance will interact. In this particular class, we had 10 students. It was a year 1 class, and the task for this particular assignment in 10C was to analyze temperature data from the 4 IoT meteorologic stations that we had on campus. And this particular slide shows you a picture of one of the IoT stations. We see that we were measuring wind speed, wind direction, relative humidity, atmospheric pressure, rainfall, and also light. We asked the students in this assignment to look at the period of recording from 15 March 2018 through 26 March 2018. And in particular, we asked the students to identify 4 trends in the temperature data and explain why you could see these trends. So this is the IoT dashboard that we used with the IoT network and program at NIE. It was the server and the host was ScienceScope in the UK. We see that, again, a number of sensors were attached to each of the 4 sites, the 4 meteorologic stations around the campus. On the right, we see the aerial view of the campus and the meteorologic stations. There are 3 green dots and 1 yellow dot. So those are the locations of the MET stations scattered around the campus. Within the dashboard, we got different types of information, as we see here in this slide. It provided us both graphical information, which I'm not showing, but also numerical data. So you can see that each station had a summary of statistics for that time period, for, in this case, air temperature, where we were getting the mean, the median, the mode, minimum, maximum, and range of temperatures at the 4 meteorologic stations. What we had the students do is, as you can see in this dashboard option, there's a download button here, and so we had the students download the data from the server and then load the data into or organize it within the Excel spreadsheet. So they were having to do some, become familiar with numeracy and software and data management. One of the things that we asked them to do was to assign missing data a value of 0 as kind of a first approach to cleaning the data, and that was something we also asked the students to discuss in their assignment, was to evaluate whether it was meaningful to put a value of 0 and how that impacted their analysis if you used a value of 0 for missing data. As we see in this slide, the results of the IoT meteorologic stations are graphed in Excel. And this is an example of one of the students, Ko Yifan's results. And we can see a number of trends here that the students also identify. We can see the daily cycle where we have peak temperatures in the daytime and lower temperatures at nighttime, we see that there's a greater difference between the 4 sites in the daytime, whereas at nighttime there's a much smaller difference between the 4 sites. We see that there's sometimes a flat response at a couple of the sites. This represents a time of malfunctioning sensor. We also see that the NIE canteen in the blue line generally is cooler than the other sites, and this made sense because this particular site was located in a forested area on the campus, and so the students could see that the shading, for example, impacted the energy budget for that particular site, resulting in lower air temperatures. We also see later in the time series, later in the week, that overall the temperatures were cooler than they were earlier in the week. The students were able to look at the rainfall record from the IoT meteorologic station and determine that had been a cloudy and rainy period, and so it made sense then that the air temperatures were cooler. So in looking at all of the responses of the students, we can summarize their responses in this slide. 90% of the students were in fact able to make a link between the differences in the daily variations of shortwave, long-wave radiation, and energy budgets and temperatures. So they were able to link what they had learned the previous semester about energy budgets and then explain that as it was reflected in the temperature data. All of the students also provided a very good discussion about problems in cleaning the data, and particularly the problem of replacing missing data with a value of 0. The students also unanimously were able to identify suspect data. This was the flat response, and explain that this would suggest that the sensors were not responding properly. A little trickier, only 40% of the students were able to actually make some more difficult links with respect to sensible and latent heat. But interestingly enough, a couple of the students also were creatively able to discuss the role of the pond, which was near one of the meteorologic stations, and how the temperature and volumetric heat capacity in the pond could impact peak temperatures during the day at that site and actually act as a cooling agent, and that was reflected in a number of days. So that was a good pickup on their part. Generally then, the students really were able to identify daily trends, identify issues of spatial variation at the sites, and overall did quite a good job on the assignment. Okay, turning our attention to the second assignment, which was the Year 3 class. This was the AAG 33B class, the Conservation and Catchment class. For this assignment in the Year 3 class, we used the PC Swim model to evaluate the impact of the NIE rain garden on runoff going into a local canal. And we were looking at 2 scenarios here. One with the rain garden constructed, the other scenario without the rain garden constructed. And because of the construction and so on, this was a really very authentic problem. It was something that's going on quite regularly in Singapore as a flood management technique implemented in Singapore. And so really the students will see this type of flood management design on a day-to-day basis throughout Singapore. So we thought that this would be a good, authentic problem to investigate. In order to have an idea of what I'm discussing with respect to rain gardens, what I'm going to do right now is turn to a very brief video that explores the whole procedure of designing and constructing the rain garden and how this was all tied into a number of different classes in geography at NIE. This is the story of our rain garden at NIE. Rain gardens are one example of what is known as low-impact development technology. Other examples of low-impact development technology include green roofs, grass swales, porous pavement, rain barrels, and even planting trees. Low-impact development technology works with nature to manage the volume of stormwater runoff and reduce localized flooding, as well as improving the quality of stormwater runoff. This video begins by discussing the general principles of rain garden design and then shows the steps of the design, construction, and monitoring at the NIE Rain Garden. Let's begin our journey. A rain garden, like the one at NIE, will be constructed using several different substrate layers, as shown here. Different types of plants also are included to help remove nutrients, maintain infiltration rates, and protect the substrates from erosion. The stormwater runoff flows into the rain garden, where it is stored at the surface and then gradually infiltrates through the substrate layers. The process reduces the rate at which runoff reaches the storm drains and therefore also reduces the risk of localized flooding. This figure shows a hydrograph for a small river or drain under different land use conditions. The blue line indicates the hydrograph expected for a storm if the land around the drain is relatively natural, with lots of forest and parkland. The tan line indicates the hydrograph expected for the same storm, but with a more typical urban land use of roadways, buildings, and concrete. The water no longer can infiltrate and be stored in the soil. Under this situation, a greater volume of runoff reaches the drain more quickly because of the impervious surfaces, and this results in a higher and earlier peak. As such, there is greater potential for localized flooding. The green line shows how low-impact development can work. By infiltrating and storing water, low-impact development technology gradually releases stormwater runoff to the drains, thereby reducing the peak flows. In the example of the NIE rain garden that we see here, there's a special 100 millimeter deep anoxic layer just below the upper loamy soil filter media. This anoxic layer is created through a mix of mineral substrate and wood chips. As the wood chips decay, the layer becomes reduced or oxygen deficient, and this enhances the process of denitrification. Denitrification removes nitrate, or NO3 negative, and nitrite, NO2 negative, that are constituents of the infiltrating water and transforms them into nitrogen gas that can be released to the atmosphere. A reaction could look something like this. In this case, the CH2O is a generic carbon source that is represented by the wood chips. In addition to the anoxic layer providing a level of treatment, the plants and substrates will filter and absorb suspended solids and associated nutrients and other contaminants. The roots of the plants will take up nutrients and contaminants, and these will be locked in the biomass that will be removed upon harvesting. The infiltrated water in the NIE rain garden collects in the underdrains, which are 100 millimeter diameter perforated plastic pipes that run parallel to each other at the bottom of the rain garden. The water then leaves the NIE rain garden through a collection sump and then onward to a nearby drain. Rain gardens can have two different designs to drain the water. The simplest and least expensive design is known as a soak-away rain garden, where the water simply continues to infiltrate downwards out of the rain garden. This design can be implemented if the soil percolation rates are sufficiently high. If percolation rates are too low, then the rain gardens must be designed with an underdrain to move the water away and avoid rain garden saturation and ponding. So, in conclusion, we can see that the rain gardens have a dual purpose of managing stormwater runoff volume and also providing a level of treatment for the runoff. Let's now take a look at the process behind the construction of the NIE rain garden. The NIE rain garden was constructed as a partnership between PUB, AECOM, Green Earth Consultants Limited, and NIE. The first step in the process was to determine where the rain garden should be constructed. Based on campus visitations and surveys, a total of 7 candidate sites initially were identified. As we see here, preferred sites were then identified based on further site inspection and a scoring framework. Included in this scoring framework was an assessment of the soil percolation potential, catchment area, catchment slope characteristics, visibility to the public, presence of utilities that might require diversion, and potential for interrupting school schedules. Site 7, an open grassed area between the art gallery and the playhouse, ultimately scored the highest and became the selected site. While AECOM was conducting its site assessments, a parallel assessment was done at Site 5 as part of the third-year Ecosystem Dynamics class in the Geography program at NIE. The students identified catchment area, measured slopes, analyzed organic content and texture, and determined infiltration rates. The students were asked to determine, based on their investigations, whether Site 5 was suitable for a rain garden. While most concluded that the physical characteristics of the site were suitable, a number of students noted that it was a less desirable site because it was not a high-traffic area or readily visible. Shortly after the students completed their assignment, Dr. Stephen Tan, the lead from AECOM in designing the rain garden, gave a lecture in class about rain gardens and PUB water management philosophy. Students were happy to see that many of the same tests that they applied in their test site also were used by the consultants. Once the preferred site was selected, the NIE rain garden design began in earnest. Because of the soil characteristics, it was determined that an under-drain design was appropriate for this site. The plan view of the rain garden design, showing the bottom layer, can be seen in this diagram. The dashed black lines indicate the location of the two parallel underdrains that eventually join near the collection sump. Here we see the selected site before construction began at the end of September 2016. The AECOM team can be seen digging a small pit to assess soil percolation rates. This is the landscape architect's vision of what the site was to be. Now, let's see how the vision became reality. The official handover of the rain garden occurred on February 1st, 2017, with staff from PUB, AECOM, Green Earth Consultants, and NIE attending. A new batch of students in the Ecosystem Dynamics class also attended, as their first assignment became the first post-construction evaluation of the rain garden. Students were asked to identify the plant types and why they were placed in certain locations. They measured infiltration rates, and they also analyzed the texture for different substrates. Subsequently, fourth-year students are conducting water budget studies and nutrient mass balance studies in the rain garden. These studies are aided by an IoT meteorologic and flow monitoring station. Preliminary results for suspended solids and nutrients show that the rain garden is effectively improving water quality going to the drain. The NIE rain garden already has provided benefits to the environment, and it offers a unique opportunity to conduct long-term monitoring of performance. This information will help inform future designs and maintenance practices. The NIE rain garden also is a wonderful resource that helps enhance eco-literacy at all education levels and allows students to participate in an innovative and eco-friendly approach to water management. Okay, so that was a brief video to give you some context with respect to the design and the construction of a rain garden, how it functions, and how the rain garden could be used in different classes, both from a design perspective, but also from the construction and post-construction monitoring perspective. So with this particular class then, AAG 33B, which is the Catchment Management and Conservation class, we incorporated a number of different learning components to the class. First of all, we wanted to integrate past years' experiences with respect to data collection, data analysis techniques, including infiltration measurements, rainfall analysis, and water budget concepts. We also wanted to tie these concepts into some overall general themes that are recurring within the geography curriculum in Singapore, and that in particular is sustainability and urban livability. We also then wanted to take things a step further, a little more detail, and connect things to pedagogical content knowledge with respect to modeling and tying all of these components of the environment and IoT together under an urban flood kind of program. So why did we introduce the students to modeling in the first place? What we see in this particular slide on the left, that's the NIE rain garden as we would see it if we were standing there. So really what we need to do is to go from real life to representing that rain garden in a mathematical model. And that's what we're seeing on the right-hand side of the slide. So this is the PC version of the stormwater management model, and how it would represent that rain garden that we see on the left in real life, how it would be represented schematically and ultimately mathematically, so that we can explore different design and construction scenarios. Information that gets fed into the PC swim model would include infiltration measurements. So we see students here on the left, for example, measuring infiltration rates into the rain garden itself. That was one of the student assignments, because that information has to go into the mathematical model. We had other year one students measuring infiltration rates in other areas around the catchment area, the grassed area that distributes water into the rain garden itself. We see here the IoT meteorologic station that is right beside the rain garden. And again, we're measuring wind speed, wind direction, atmospheric pressure, relative humidity, and rainfall. And this information went into another assignment, for example, to estimate evapotranspiration rates from the rain garden. And that information about evapotranspiration rates also went into the mathematical model. So we built progressively by providing different assignments for the students. Progressively, they developed information and data that finally got fed into the model in their third assignment. And this is what we see here in this slide as the mathematical representation of the catchment area for the rain garden. So the yellow line that we see here is the underdrain in the rain garden going out to the canal, and the pink area that we see here is the catchment area for the rain garden itself. So this would be the area that is contributing the runoff to the rain garden. This is how the rain garden and catchment area system would be represented visually within PC Swim. If we look at the model results, the students were asked to run two different scenarios. One scenario was with the rain garden there, what would the runoff in this yellow drain look like? The other scenario is if we had no rain garden, what would the runoff look like going into the drain? So what they did, and these are the model results that the students produced, we used the rainfall data from the IoT Met Station as input to the model. And the gray line that we see up top here are the actual rainfall data that were recorded for a one-day period at our Met Station. So we see that there were actually 3 storm events, 3 rainfall events through the day. The model then takes that rainfall data and produces runoff by accounting for things like infiltration, which the students have measured, for example, accounting for evapotranspiration, again, which the students had measured. So the flow that was produced by these rainfall events, in this case, are shown in the blue line. So this is the flow rate. Now I'll emphasize that the blue line is the flow rate without a rain garden. So this is what the water flow would be going into the under drain pipe if there was no rain garden there. And we can see that the peak flow for the biggest storm event is about 0.007 cubic meters per second. And we can see that the peak predicted runoff or modeled runoff matches up quite well with the peak rainfall intensity that we put in. Now there's a second set of lines that you can't see, but I've circled it in red, and that's the scenario with the rain garden in place. And we don't see anything here because the flow is so small related to this scenario, because the rain garden essentially is absorbing all of the water and storing that water within those different substrate layers. So there's very, very little runoff. And so the students were able to see the impact of, or the benefit of, building a rain garden to reduce runoff and to reduce localized flooding in this modeling effort. So, in conclusion, we can say in this session that the IoT environmental sensors and data were successfully integrated into a number of different geography courses at NIE in Singapore. The IoT technology really successfully underpins improved pedagogical content knowledge for student teachers, but also for in-service teachers in Singapore. And in particular, the IoT technology helped to support development of 21st century skills that include critical thinking, collaboration, communication, and technology literacy. So thank you, and with that I will conclude this part of the session.
Thank you, Prof. Kim. And now we are turning to the discussion section. Chúng ta vừa lắng nghe cái bài trình bày của thầy Kim rồi ạ. Thì không biết quý anh chị, thầy cô có đặt câu hỏi hoặc là cái wrap up xem mình có cái cảm nhận gì hoặc là nhận xét gì trong cái bài trình bày của thầy không ạ? Chúng ta chắc là mời một thầy cô có ý kiến thôi ạ. Như chúng ta thấy thì thầy Kim trình bày cái việc ứng dụng IoT trong các môn học, đặc biệt là trong môn của thầy thiên về sự ứng dụng trong GIS, địa lý, cũng như là trong vấn đề quan trắc, hoặc là cho sinh viên biết là cái việc có cái rain garden như vậy thì nó như thế nào đối với cái chất lượng nước đi vào cái hệ thống khi mà nước mưa xuống. Thì không biết mình có ý kiến gì không ạ? Có thầy cô nào dạy môn nào giống như môn thầy trình bày ở đây không? Và mình không biết mình ứng dụng như thế nào, cái việc IoT mình đã và đang ứng dụng như thế nào trong các môn học của mình. Hay là quý thầy cô cũng có thể đặt câu hỏi hoặc là học hỏi thêm từ thầy trong quá trình đó thầy gặp khó khăn gì, hoặc là thầy có lời khuyên gì cho
Dạ, em xin giới thiệu em là giáo viên trường Trung học phổ thông Ngô Quyền quận 7. Môn của em giảng dạy là hóa học phổ thông. Thì qua theo dõi cái phần trình bày của thầy Kim á, thì em hiểu là thầy đang giới thiệu cái việc ứng dụng cảm biến môi trường vào trong cái phần giảng dạy địa lý của thầy qua hai ví dụ cho sinh viên năm 1 và sinh viên năm 3. Ở cái phần thiết kế cái bài học cho sinh viên năm 1 á, thì học sinh đã vẽ được đồ thị, phân tích thống kê, giải thích dữ liệu nhiệt độ qua cảm biến bức xạ nhiệt độ qua cái phần trình bày của thầy đó. Sau khi các em thống kê dữ liệu trong 11 ngày từ 4 cái trạm khí tượng theo yêu cầu của thầy, Các cái địa điểm này là ở Singapore, như là cái căng tin khu vực Nye, em hiểu là như vậy, hoặc là Blazer của Nye, hoặc là cái hồ Nye, hoặc là cái Rain Garden, tức là cái vườn mưa của Nye. Rồi mấy em lấy thống kê và đưa ra những cái phân tích rồi thảo luận. Thì cái phần này em không chuyên về địa lý nên em chỉ hiểu rằng là đây là một cái bài giảng, một cái phần giảng dạy của thầy mà giúp cho sinh viên có thể là vận dụng được các cái cảm biến IoT, cảm biến môi trường, cụ thể là cảm biến bức xạ, cảm biến nhiệt độ, rồi vận dụng một cái app là app vẽ đồ thị phân tích dữ liệu, để từ đó các em đưa ra những cái nhận xét đánh giá trên cái nền là phân tích số liệu môi trường đó. Thì em biết là như vậy thôi. Rồi cái bài giảng thứ hai của thầy cho sinh viên năm 3, cái này nó có vẻ là liên quan với hóa của em một chút. Và em sau khi mà em nêu cái hiểu của em về cái video này thì em xin thầy cũng giải thích cho em một số câu hỏi. Đối với sinh viên năm 3 thì các bạn này dùng các cái cảm biến môi trường IoT để mà làm cái việc là xây dựng cái vườn mưa, và kết hợp bên đó là mấy bạn sẽ đánh giá cái dòng chảy, rồi cái lượng mưa, những cái thông số liên quan tới cái dòng chảy sau mưa đó, để mấy em sẽ so sánh là nếu mà có cái vườn mưa và không có cái vườn mưa thì cái tác động đến cái hệ thống nước thải nó như thế nào. Thì em có thấy liên quan tới hóa của em là nếu như mà nước nó đi qua cái vườn mưa rồi thì sau một hồi thì các em sinh viên năm 3 sẽ nhận thấy là có cái phân tích là cái dòng chảy nó sẽ giảm, có thể không gây ra lũ lụt, bởi vì cái mức đỉnh của cái dòng chảy nó không đáng kể luôn sau khi đi qua vườn mưa. Và đồng thời chất lượng của cái nước thải ra khi mà đi qua cái vườn mưa theo phân tích thì có vẻ là tốt hơn. Thì em muốn biết là bây giờ cái vườn mưa này, em có nhìn trên video em thấy là có cái hệ thống thoát nước từ cái vườn mưa, thì em muốn thầy làm rõ hơn là bây giờ muốn đưa ra được cái kết luận cuối cùng là cái vườn mưa giúp cho cái việc cải thiện môi trường, giảm lũ lụt đó, thì là thầy so sánh với dữ liệu nào, bên ngoài vườn mưa hay không, rồi trong có cùng thời gian hay không, cùng thời điểm hay không. Và thầy ngoài cái chuyện sử dụng cảm biến môi trường đó thì có cái công nghệ phân tích dữ liệu gì nữa để giúp cho các em sinh viên hoặc là các em học sinh sau này nghiên cứu khoa học ở trường phổ thông mấy em có thể sử dụng được, và có thể ở trường phổ thông mức độ nhỏ hơn thì có thể là vận dụng này cụ thể là như thế nào nữa. Nhất là thành phố Hồ Chí Minh mình nè, cái vấn đề ngập lụt là giống như là đặc sản vậy đó, thì cái này rất là hữu ích, rất là tốt cho thành phố mình, mà đặc biệt là các em phổ thông, các em có thể thực hiện những cái đề tài nghiên cứu khoa học cấp độ nhỏ sau này vận dụng lớn lên là cho đô thị mình luôn và các đô thị khác đang phát triển. Em cảm ơn thầy. Cảm ơn.
Em xin phép dịch câu hỏi cho thầy Kim để thầy Kim trả lời cho cô luôn ạ. Sorry, Prof. Kim, we have one actually comments and questions from one lecturer in our site, and she is a lecturer, and her her major is chemistry courses in high school, and she does understand two of the courses you apply the ITO in your classes for first year and third year students. And she has questions on the second one, which is about the courses for the third year students, and specifically the design of the rain garden to control or reduce the flood risk. And she's wondering what could be the measures or the comparisons to other, whether it is there any comparisons with the outside of the garden to say that the rain garden could help to reduce the flood risk. And especially this is would be helpful if besides this tool of the IoT, or environmental sensors? Is there any other tools or applications so that the high school students in our country can apply in their study or research? Especially flood is one of the controversial problem in Vietnam mega cities. Yeah, thank you.
Okay, thank you. Excellent questions. We're still wrestling with some of them. So to maybe break things down a little bit, first of all, particularly for chemistry and say environmental science, the rain gardens are able to have a dual purpose. One is for improving runoff quality. The other is for managing water quantity, so flooding issues. For the water quality side, especially for chemistry, say, and environmental science, basically because of the absorption and adsorption and uptake by plants as well as physical filtration, one of the issues that is important in Singapore and other areas is to look at how these rain gardens can manage nutrients in runoff. So for example, in Singapore, about 2/3 of the island's surface is used to collect runoff going into the drinking water reservoirs. So the cleaner the runoff going into the reservoirs, the less treatment costs and the less problem with eutrophication. So in one sense then, for managing water quality, what you can do with the rain garden is to take samples, and this wasn't shown so well in the video, but at the different inlet points to the rain garden, you could do one of two things. You could have the students manually take water samples, collect water samples, and then do tests on nutrient levels, nitrogen and phosphorus. Alternative, and then also measure the runoff leaving the rain garden. And that's what the bar graphs were showing at the end, a comparison of two input sites and one output site. So you can look at water quality that way and try to determine the benefit of improving water quality. There are sensors that you can get for, particularly for nitrogen, that could be tied into IoT so that you could do this type of monitoring in real time. But in that sense, they're probably a little bit less accurate, these sensors, than doing something with the manual samples. So that's the water quality side of things. As far as flooding goes, yeah, we actually just at the end, and I wasn't able to show this, but we actually did install flow meters, and these can be also IoT sensors at the inlet points, and this will depend on your rain garden design. But you can install flow sensors at the inlet points and at the outlet point. You can also install, which we did not have, but they are available, you can install soil moisture sensors. So at the different levels or the different depths of the rain garden, you can measure how wet the different layers are. That gives you an idea of how much water is being stored. And so you can get then a measured water budget by measuring inputs and outputs and storage. So that will show you the benefit of a rain garden or green space. I mean, also if you had a park, you could do something like that with green space. Where I am right now in the Faculty of Architecture and Planning at Thammasat, we have a very large program in landscape architecture, and the Smart City project that we'll talk about in the third session today very much is looking at designing rain gardens and green space, including constructed wetlands, to manage stormwater runoff. And so the group that I'm working with really is more interested in how to do these kinds of designs because they're landscape architects. but I'm also working at the same time with environmental engineering students from AIT who are taking, and I'll talk about this a little bit later, but who are taking the landscape designs, the wetland designs, the rain garden designs, and actually doing the modeling to try to determine before you build these water sensitive urban designs, how effective will they be potentially, how much will they cost to build, and what are the benefits, so before you actually implement anything.
Okay.
So hopefully that answers the question. That was a bit of a long answer.
Mic. Okay. 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 Okay, Prof. Kim, we got you, and you are in the right track. You answered the questions from our lecture, and I'm going to translate for the lecture. Em xin phép dịch cái câu trả lời của thầy Kim cho cô ạ. Thứ nhất thì thầy nói là cái việc ứng dụng IoT trong cái bài giảng cụ thể là cho cái học sinh viên cấp năm 3 đó là có hai cái lợi ích. Thứ nhất là cái việc thiết kế cái rain garden, cái vườn mưa này nó sẽ có việc hỗ trợ trong việc cải thiện cái runoff, là nó làm giảm cái độ runoff chảy tràn á, để nó giảm ngập úng. Thứ hai là nó cũng giúp góp phần để mà kiểm soát được cái chất lượng nước khi mà nó đi vào cái hệ thống thoát nước mưa của thành phố. Và cái việc mà đảm bảo cái chất lượng này và cũng như cải thiện cái chất lượng này thì nó thông qua cái việc hấp thụ hấp phụ cũng như là lọc của cây. Thì khi cây mà nó được cái nước mà nhiễm bẩn á, thì thật ra bẩn đối với mình nhưng mà tức là nó là nutrition, nó là chất dinh dưỡng cho cây, thì cây nó sẽ hấp thụ cái chất dinh dưỡng đó và nó lớn. Thì quá trình đó cũng là một cái quá trình lọc tự nhiên từ cái nhu cầu của cây. Và nó sẽ giúp cho cái việc mà giảm cái chi phí xử lý nước thải. Thì để mà cho sinh viên biết được cái việc cái vai trò của rain garden, cái vườn mưa trong cái việc cải thiện chất lượng nước, thì chúng ta có thể cho sinh viên học sinh lấy mẫu thử trước và sau cái rain garden đó. Cái nước bắt đầu mưa xuống thì mình có một cái mẫu mình lấy ở đó, và sau rồi mình lấy luôn thì mình đi gửi đi phân tích, hoặc là cho sinh viên tiến hành các phân tích, học sinh tiến hành phân tích để có thể đo cái nồng độ dinh dưỡng cũng như là cái tỷ lệ phosphate ở trong nước. Thì chúng ta sẽ biết được là cái vườn mưa đó nó đã hỗ trợ góp phần là ví dụ như cải thiện chất lượng bao nhiêu %, ví dụ như vậy. Và thứ hai thì trả lời câu hỏi về cái sensor, thì ngoài cái sensor mà thầy sử dụng thì thầy có đề xuất là chúng ta có thể thực ra là thầy có hướng dẫn trong cái bài giảng nhưng mà có thể chúng ta không để ý, đó là có dùng cái flow meter, cái đo dòng chảy. Chúng ta có thể cài lắp đặt cái đo dòng chảy ở trước khi bắt đầu vào của cái rain garden với lại sau, thì chúng ta sẽ biết là cái độ dòng chảy nó đã thay đổi như thế nào, thì nó sẽ góp phần làm giảm cái runoff, cái độ chảy tràn như thế nào. Và chúng ta cũng có thể cài đặt thêm cái sensor để đo độ ẩm của đất. Thì cái độ ẩm của đất đó cũng góp phần cho chúng ta biết là cái vai trò của cái rain garden trong cái việc cải thiện cái độ cải thiện chất lượng ô nhiễm nước, hoặc là cải thiện cái runoff. Và thầy cũng có giải thích thêm, thì thầy cũng có thầy đang làm việc ở cái ngành này về kiến trúc và thiết kế, nên thầy cũng có làm việc thiết kế wetland. Wetland là rừng gọi là dạ đúng rồi, wetland, rồi cũng có thiết kế rain garden, và cũng như là thầy thiết kế cái landscape cảnh quan đô thị, thiết kế cảnh quan đô thị, và cũng có làm việc với các sinh viên bên ngành kỹ thuật môi trường của trường đại học của học viện IIT để tiến hành monitor. Thì thầy đề xuất là chúng ta thường xuyên thực hiện các hoạt động monitor, quan trắc để mà chúng ta biết được là cái chất lượng nó đã như thế nào, cũng như là cái vai trò của Grand Garden nó được đóng góp như thế nào trong cái môn học đó. Yeah, I think we don't have much time, so there was only one question comment for your side. Yeah, thank you very much.
So we're going to have to continue to the second presentation. Kính thưa quý thầy cô, thì mình sẽ tiếp tục lắng nghe cái bài trình bày thứ hai của giáo sư G, cũng là cùng anh Tuấn muốn đặt câu hỏi thêm ngay bây giờ. Professor Kim, are you still there?
I am.
Thank you. So we are welcoming to the last question to your presentation. Sorry, and stay with us for a while.
Xíu nữa có thời gian thì mình sẽ quay lại mình nói cái này, tại cái này có nó thuộc chuyên môn cũng mình cũng nghiên cứu khá lâu về cái này. Tuy nhiên có thầy Kim ở đây thì mình chỉ hỏi hai cái ý thôi. Cái ý thứ nhất là với cái ở này là một cái trường học thì cái kinh phí để mà đào tạo mà thiết kế xây dựng các cái mô hình này á thì được nhà trường tài trợ hay là tổ chức chính phủ như thế nào đó tài trợ. Cái thứ hai nữa là mỗi một cái đợt năm học làm như thế này thì cái duy trì á sau này như thế nào đó, thì cái đó nó cũng ảnh hưởng tới cái thực tế của Việt Nam chứ, tại vì sinh viên của mình mà để làm được cái mô hình mà để thu thập như thế này thì cũng ra rất là nhiều, cũng phải có dự án tài trợ hay là như thế nào đó thì mới có được.
Sorry, Prof. Kim. Yeah, take the advantage of when you're here. So he just want to ask for one small part, small but crucial, which is about the financial support, especially for Vietnam cases. Student, we are not sure in your cases how students are supported in terms of the funding for designing such practical parts or even for the monitoring part, as you suggest, because for the case of Vietnam, we don't have much support, especially from the university or school, to the student to do such practical activities. Thank you.
That's a very good question and a critical question. In our case, and to be honest, our rain garden at NIE was over-designed, but that was funded by PUB because it was meant to be a showcase and demonstration project. So it would have been fairly costly to do something of that size. However, schools in Singapore now, the PUB did put in rain gardens at about 10 schools as the next round of demonstrations. But subsequently, we've been working with some of my former students. So all of the students at NIE that were shown in the video, all are going to be teachers. So basically, they're going out to schools once they graduate from NIE. If you're going to be a teacher in Singapore, you're going through NIE. So those were all pre-service teachers that I was working with. We got several calls from several different schools from former students once they went out, interested in rain gardens, and they actually did various combinations. Sometimes they hired a landscape architect on a very, very shoestring small budget to design the rain garden and help them construct it. But the students also had input to the design. So it was possible for the schools to do something like that creatively. I would suggest, and it would be helpful though, to partner for the schools to say partner with the university and try to develop those kind of collaborative efforts. The IoT sensors themselves can be done fairly cost effectively. The key, and there are lots of different sensors available on the market. So the key there is to select the sensors that would be of greatest interest to you. And then that case, it will take a small budget, but it can be done because the IoT sensors are quite cost effective. That may not be probably a perfect answer for you. Ultimately, yes, it will take some funding, but I think what is crucial here is to collaborate also, again, between schools, universities, and to help exchange both information and resources.
Thank you, Prof. Kim. Yeah, I'm going to translate your answers. Dạ, thầy Kim có đề cập tới đây là một câu hỏi rất là quan trọng. Và đúng là nó rất là khó trả lời, nhưng mà trong cái trường hợp mà như của sinh viên cũng như là của bên Singapore á, thì nói là một phần cái nguồn kinh phí là từ cái PUP là Public Utilities Board, là giống như là cái hội đồng công, Public Utility là dạ đúng rồi, của bên Singapore thì là họ hỗ trợ, nó giống như một cái dự án thí điểm vậy đó, để có thể là cho học sinh, sinh viên hoặc bất cứ một cái nhà practitioner thực hành nào họ có thể đến tham quan, quan sát và họ có thể học hỏi từ đó. Thì thầy cũng có suggest nếu mà nhìn từ quan điểm của trường đại học hoặc các trường cấp 3, các trường học á, thì chúng ta có thể kêu gọi từ former student là những cái cựu học sinh, cựu sinh viên, thì họ có thể đóng góp vô một phần nào đó thôi chứ không có chắc là hoàn toàn, hoặc là có thể kêu gọi partner, những cái người cộng tác với trường, với trường đại học, ví dụ như cái trung tâm IoT hoặc là bất cứ một trung tâm nào đó mà họ có thể hỗ trợ, thì cái đó là một cái suggestion cho thầy, nhưng mà thầy không biết là có chắc chắn hay không, nhưng mà thầy có đề xuất như vậy. Thank you very much. Yeah, maybe we will turn to the next presentation.
Okay, thank you.
Thank you.